Hey everyone, so continuing on with our discussion about vectors in two dimensions, another thing that we have to include is this idea of being able to kind of sketch a rough idea of the resultant vector. So if I give you two vectors, you should be able to come up with generally what that vector should look like, what direction it's going to point in. Now it is very similar to what we did in the previous part, but we want to kind of um, figure out some easy tricks to be able to do these questions. So we've already figured out how to do it when they're perpendicular, but a lot of times you're going to end up having them come in at weird angles to each other. Now, as I said before, a lot of times you might be asked to figure out when they're at these weird angles, figure out what the actual resultant is. Usually that's done for a free response, and you're being asked to do it graphically. And when it's in this complex setup, so it's not at a right angle, you're going to want to actually solve it graphically. There is a way to do it mathematically, but you won't have the equation on hand during the test, and you may not remember how to do it. So, uh, the other thing is the being able to do a quick sketch like you would normally see in a multiple choice question. So I'm going to go over both of those. So let's say that we had a question where we had an object being pushed. So in this case, a boulder. Two people are pushing on it, and they're pushing on it in this way. So one person's pushing it straight down, and another person is pushing it off on an angle. So it is also going down, but also going to the left as well. Now the question is, what is the resultant direction of the push that's coming from this? So what we can do, we're going to want to actually redraw these arrows tip to tail. Again, we're basically doing what we did before, where we create a little treasure map of the vectors that are going on and then draw the resultant from start to finish. So what we're going to do didn't move, but we want to redraw this arrow so that it actually starts at the tip of the other arrow. And then again, the resultant goes from start to finish. The reason why this is important is because before, when I gave you vectors, uh, we kind of gave them out as directions. You know, you go north, then you go east, then you go south. So you just made the path yourself. Uh, or if we did give you a diagram, it was already drawn properly. Now, what we're going to end up getting is we're going to get vectors that are drawn what they call concurrently. So, concurrently means acting at the same time on the same object. That's all it means. Uh, for the most part, you don't even have to worry about it. But it's things like this, where you can have an object being pushed like this, or maybe it's starting from the same arrow, kind of like what we saw in some of the earlier questions. The main idea is that they're not drawn tip to tail, so you kind of have to draw them that way in order to actually figure out the answer. So the idea is that if we have person one pushing in this way and person two pushing in this way, then the boulder or the object is going to feel a resultant force going in this direction. This is the results of one and two, and that's pretty much it. There are other ways of doing this. So, for example, so here's that word concurrently again. Again, it just means act on the same object, same place, same time. Another thing that you can do is, besides doing a quick tip to tail, you can also create a parallelogram. All right, I don't know why it's not. There we go. You can also do a quick parallelogram. You've actually done this in math before. I'm positive that you were given questions where you had arrows drawn like this, and you were basically told to create a parallelogram and then draw a line that goes from one corner to the other and find what this diagonal was. That's exactly what we're doing. So what I always recommend is when you see lines, vectors that are acting concurrently, starting at the same point or pointing to the same point, what you want to do is create a parallelogram from that and then basically draw an arrow from one corner where they start to the corner where they end. And then that's your resultant. Again, because the whole idea is that order doesn't matter. It doesn't matter if we follow the blue line, then the red, or if we follow the red line, then the blue line. All right, so here are some questions. Pause video, work on self, and we'll go over in a second. All right, so once again, we have two vectors that are concurrent. So they're starting at this point and they're going outward. So we want to find the resultant. The way we're going to do this is by making a parallelogram. So I'm just going to draw it as best I can. I don't have to be an artist. My resultant is going to start where they all start and end where they all end. So the only one that looks closest to this is choice C. And that's it. Here's the next question. Pause the video, work on itself, and we'll go over in a second. Alright, so we need to see which of these would actually produce this resultant. So for each one of these, I'm just going to make a parallelogram. So redrawing this bottom line up here, redrawing this line over here, the resultant is going to go up and to the right. So this can't be it. Doing the same thing here, this line gets drawn on the bottom, this side gets drawn on the side, resultant goes from where they start to where they end. This one's also not looking like that. Okay, so then we have this one, drawing that line, drawing this line, and resultant looks like this. Alright, let's just double check this to make sure, but this is most likely my answer. Again, I'm just making a parallelogram going from start to finish, and yes, these two look the same, so my answer is D. Here's the next question. Pause the video, work on self, and we'll go over in a second. Alright, so here they've switched it up. A and B are our vectors, and R is the resultant. Meaning, again, the resultant points to my start and points to end. So if I follow along vector A, vector B has to bring me back to this endpoint. So that means the only vector that would do that would be to do this. So the answer is B. You want to pay attention to what they're giving you, because they don't always give you the two vectors and ask for the resultant. Sometimes they throw a little curveball, give you one vector and the resultant, and ask for the other. So always pay attention to what you're given. Alright, this is another side thing with vectors. It's something that I want to just mention really quickly, but you want to know the angles that will produce the greatest and smallest resultant. And the idea is that any angle between there will result in a resultant between those numbers. So when you have two vectors that are acting at 0 degrees, meaning pointed in the same direction, so two people pushing together, that's going to produce your largest results. So if you're pushing to the right, if you want to get the largest results, you want another person also pushing to the right. Hence the phrase largest resultant. The resultant will just be the sum of the two vectors. So if they're both going to the right, you add them up. Again, you can always consider these as being displacement vectors, and then asking yourself, what would give you the greatest result? Moving in the same direction. So 0 degrees is same direction. Then on the flip side, two vectors acting at 180 degrees, so going in complete opposite directions. This would produce the smallest results. So if you're trying to move a table, the smallest results possible would be if you're pushing in one direction and another person is pushing against you. That would give you the least results possible. And the resultant from here is the difference between these numbers. So if we used these examples before, let's say I'm pushing with 5 newtons and my son pushes with 3 newtons. then we're going to push for a total of 8 newtons of force. But on the other side, if I'm pulling in this direction with 5 newtons and he's pulling in that direction of 3 newtons, then we're going to end up resulting in 2 newtons of push. And then the idea, again, the thing that I really want to stress is that these two numbers, 3 newtons and 5 newtons, can create any number between 8 and 2 based off of the angle. So something like pushing at these weird angles would produce a number between 2 and 8. So this could be a good way of kind of figuring out whether or not you're on the right track with your answers. Here are some of the examples that I gave before. All right, so here's a question. Pause video, work on itself, and we'll go over in a second. All right, so the question is, which one would produce the greatest force? So we want to figure out the greatest. Now, we said before that the best results possible will be two people pushing in the same direction. So we're looking for the one that's roughly pushing together. These choice C, they're moving in opposite direction. B and D are actually both perpendicular. So the answer is A. The most common mistake that I'll see is people will just do this and they'll say, oh, C has the longest line, so that's it. But you have to remember the way that they're drawn, you actually have to draw them in that parallelogram, and you'll find that C actually has the least, while choice A has the greatest. So definitely keep an eye out for that. Try not to be tricked. Don't just get into the habit of just drawing a line from one end of to the other and making a triangle. You have to create a parallelogram if they're starting with the same sides of the arrows together. All right, here's another question. Pause the video, work on itself, and we'll go over in a second. All right, once again, they're looking for the greatest results. So I'm looking for the one where, again, they're pushing roughly in the same direction. B is in complete opposite directions. C is also sort of in opposite directions, not as bad as B. A is perpendicular, but if we look at D, they're both roughly pushing forward. And if I draw these tip to tail, which they are kind of looking tip to tail, we can see that my resultant would go along here, very long compared to this one, let's say, which would only be much shorter. So the answer is D. All right, here's the next question. Pause the video, work on itself, and we'll go over in a second. All right, so this is going back to the idea of the components, but also relating it to these different angles. So my best recommendation is to draw this out, but also to draw it out for the most part much more obscure. So like 60 degrees, I'm going to draw like this, and then 30 degrees. So this is my triangle, and I'm going to try to draw this line about the same length, but this time I'm going to draw it 30 degrees. Kind of went a little long over there in order to get the point across. So they're looking for the vertical component. So as it goes from 60 to 30, this side is very clearly decreasing. You could have also figured this out by actually just calculating it. So you could just put a number here, let's say 5, and actually use the equation for the vertical component, and done 5 sine of 60, and then compare that to 5 sine of 30, and you would realize that the number does decrease. I think this one's going to be 2.5, and this one is going to be 4.3. So again, we see that the number decreases. Whatever floats your boat, as long as you kind of recognize how the side is going to change based off of the angle. and that's pretty much it. So uh, those two videos, this video and the last video, were recaps of some vector stuff that you have to be able to do. From this, the next video we're going to do is where we're actually going to start talking about projectiles, starting with the foundational stuff before we go into some of the heavier things. If you have any questions, please let me know. Otherwise, I'll see you later.